So in math, we've been talking about multiples, more specifically least common multiples. Now multiples are when you count by a number or you multiply that number by a different factor. So multiples of 6, for example, would be 6, because 6 times 1 is 6, 12, 18, because 6 times 3 is 18, 24, because 6 times 4 is 23, 30, 36, 42, etc. And then, so let's say we're looking for the LCM between 6 and 9. And we would do that most likely if we were trying to write an equivalent fraction and coming up with a common denominator. So let's write the multiples of 9. Multiples of 9 start with 9, 18, 27, 36, 45, 54, 63, etc. Now to find the least common multiple, I look for a common one, and the one that's common both for 6 and 9, and is the least. So that in this case would be 18. So the LCM of 6 and 9 equals 18. Now that's not all that difficult. However, if we're looking at a number like find the LCM of, in our homework 3-3, our workbook, we're looking for number 19 here is asking us to find the LCM between 4, 12, 24, and 36. Now, that's going to take me a little more time, but the book's showing us a shortcut. What they're asking us to do is, instead of listing the multiples, list the factors that make up 4, the prime factors. And we've been working on prime factorization. So the prime numbers, or prime factors that make up 4, would be 2, because 2 is prime, times 2. The prime factorization of 4 is 2 times 2. For 12, it would be 2 times 2, that's 4, times 3. For 24, it would be 2 times 2 times 2 times 3. And for 36, now you can build a factor tree, and you can determine, let's say we go 4 times 9, and that 4 is composite, 9 is composite, but I could break 4 down 2 times 2, and times 3 times 3. 2 times 2 times 3 times 3. So we've written all the factors. Now how does this help us find the greatest common multiple? Well, we're multiplying the factors to make these multiple, make these numbers, and finding the common one. So what I could do is I can take the factors of 4, 12, 24, 36. So I can write those. So I could let's start with this 2. And if there's corresponding 2's in the other numbers I'm looking for multiples of, I just write it once. I can team, all these 2's here are going to be one team of 4, so I just write the team 2 here. I just write the 2 here. And that represents this 2, this 2, this 2, and this 2. They're all lumped together as 1. I have another team of 4, 2, 2, 2, 2. That takes out those 2. And now, can't use these anymore. I have a 3 here. Now, they don't have to be in all of them. Just 2 or more of them to only use 1. So I see this 3 here is here, here, and here. So I can make this one team times 3. And I have a couple numbers here left over. I can't partner with them with any factors in other numbers. So this 2 doesn't have a corresponding 2 anymore. So I just have to list it here. And this 3 doesn't have a corresponding available 3. So I have 2 times 2 times 3 times 2 times 2. Well, commutative property says I can say 2 times 2 times 2 times 3 times 3. And that's the same thing. I'm just putting it in a different order. So 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3, so 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, and 24 times 3 is 72. So my LCM between 4, 12, 24, and 36 is 72. We'll take a look at another sample in another video.